Um, this is a report from a teaching experience that I started 2 years ago at my university. So my name is Fernando Abreu. I'm coming from one of the 3 public universities in Lisbon, which is called CAiSE'22, and that is the name of my research center. Today, besides myself, I have a guest star, which was not planned initially, but you'll know when the time comes, and the reason why as well. Okay, so let's move forward because I have lots of things to tell you. I actually have. I would like to do some fast forwarding, depending on your knowledge on the topic. So I expect for the people attending this conference that I will be able to do that, but I will confirm with a hand-raised poll in a few moments. So as I was mentioning, this is not exactly results of research, but results of teaching experience. That's why this is a tutorial and not a presentation on the other rooms. So it's a tutorial which is based on a master program, new topic that we introduced there on a hybrid program for students on second cycle on computer science and business management. It's a kind of degree for people with different coming backgrounds, and then they complement each other. Many of them are also night students, so just for you to have an idea, this is we have in this course around 60 students, 60. Started 2 years ago, and so perhaps this year I'll have something like 70. And since they come from different backgrounds, and many of them, for instance, come from companies. Okay, so they have different requirements from, I would say, normal students in a way that they are expecting to have professional tools to use stuff with the nice interfaces, and also since they work on groups, and since we also crossed the period of the pandemic, they needed to have cloud-based platforms to work together, not something that they could just install in their own computer and work alone somehow. So we had also this kind of requirements, which somehow became standards for the future. I also interested on these topics because I've been supervising students, PhD students and master students on topics related to process mining, especially on software development process mining topics. Okay, so then when I looked and knew about CAiSE'22, and I thought, wow, would it be important to provide a tutorial on this topic here? And since the conference is on an area based on the title, which is Information Systems Engineering, I did like I teach my students, let's make a search string. Actually, let's make 6 different search strings and look on a longitudinal way for many years since 2001, since this century started. How have these 6 topics: process modeling, improvement, automation, mining, monitoring, simulation, been treated in the literature? And I used Google Scholar, which is the most democratic search engine. And I was a bit surprised, I would say. And this is the result of the number of hits I got with that search string that I'm mentioning. And as you see, process simulation hasn't still went up as much as all the others. Of course, process modeling came first, and is a very widespread topic. Somehow it has reached a steady level. The others, these 2 others, process improvement and process mining, are raising up a little bit later. Process automation, also process monitoring, but so when I looked at this, it makes sense to come here and make a tutorial on this, because we have to teach people about how it is not as much difficult as it might seem in the beginning to work with process simulation, do it in the context of a classroom for teaching students. And since, well, a big majority, I would say the vast majority of researchers are also, at least at some point in time, connected to university, because most research centers are still, especially in Europe, connected to universities. So it makes sense to talk about this. So that is the motivation. I just took out the 2020, 2021 out because of the pandemic, which somehow changes these curves in strange ways. Okay, so but this was the motivation. So everybody knows what the process is as a collection of actions and changes and things that have to provide a result. I believe everybody also has an idea what a business process means. Several organizations have defined it. Of course, I will provide the slides for you. I will send you a link or provide the organization a link to the slides. So, but when in the title I included process-aware information systems, I'm specifically meaning those information systems where we can somehow capture the process, and that means that logs are available. And not all information systems we are able to get our hands on the event, especially after the Data Protection Act has popped in our lives and ruined much of our research in information systems. But somehow, either because some governments are open to deliver open data resources, which is a growing trend by governments, and also because sometimes we can do it with partner institutions. Of course, we can do it by encrypting some information. We can still do lots of work in this area, and I would say there's a huge amount of interesting stuff to be done in these topics, and somehow CAiSE is a good picture of that if you look at the program of the conference itself. Okay, so as I mentioned in the prerequisite section of the tutorial, I expect all of you are knowledgeable with BPMN, which is perhaps the most widespread modeling notation for business process management. So that's something I would expect now, but nevertheless I will make a poll in a poll and raise poll in a few moments. But before that, I would like to make an acknowledgement of gratitude to the producers of these tools, which I've been using for the last 2 years in the context of that course at my university, and also in research as well. So we've been using a bunch of tools that were developed in the context of Marlon Dumas' team and his colleagues at a joint venture between Tartu University in Estonia and the University of Melbourne in Australia, and also tools from and of course we are grateful to the Academic Alliance initiative by Opromore, because it allows us to have our students using the same tools as professionals do. And the same happens with Signavio, that was recently bought by SAP after we were already using it, and it came as a surprise for us, but no, just because we don't follow the politics and on that. But also it's a very good tool for cooperation, and it allows us to having a control about over all what our students are doing. That's very interesting. And also, of course, we've been using some more research-oriented tools that have been developed here nearby, in some nearby universities across the border in the Netherlands, on ProM, especially on Eindhoven and they actually, the Van der Aal's team was somehow responsible for that raise in process mining interest, together with guys like Marlon Dumas in Estonia. Okay, so let's move on. So my first expect to be fast forwarding step is on this topic. So I brought some collections of materials on these 4 topics, and I expect the first 2 to be able to go fast forward. So my first question is everybody confident with BPMN? Yes? Yes? Okay, so, okay, BPMN? Very basic. Okay, so I'm going to do very fast forwarding, but of course young people are used to see, I see my students putting YouTube tutorials on velocity 4 or something like that, and they can follow. I can't, but they can, so I will do mostly. So, okay, so process modeling, of course, have been around for many years. These are expected to be first process models developed many 100 years, something like 20,000 years ago. Okay, so we have the descriptive and prescriptive views of processes, and especially when we do simulation, we are of course interested in these 2 perspectives. Processes are easy to understand when you have you can see them. When you cannot see them, you have the problems of saying who's doing what, why they are doing that, what are they doing, where, when, and those 5 W's, which actually are 6 W's, because we have also the how, which does not start by a W, and that's why we need process modeling for explanatory reasons, and then we have the de facto standard, which is BPMN, Business Process Modeling and Notation, which became both a de facto standard and a de jure standard, because it's been standardized both by an American organization for standardization and also by ISO, which is the international counterpart. Okay, it's very rich language, it's widespread, and I would say is completely dominant. I tried to do Google Trends analysis with BPMN across all the others, and all the others came here, okay? CAiSE, so this is the 100% scale on Google Trends. This is a worldwide analysis. There's a huge amount of books on BPMN, and this means something. It means it's, okay, there's a huge amount of tools on BPMN modeling, which also means something because people are willing to buy them, okay, and use them. But it's a very rich language, and if you have basic knowledge, I would expect you to print this in an A3 paper, like I tell my students, print in an A3 and bring it to your assignments. I don't care if you bring this poster, because in fact it is rich to the point that I myself sometimes come and also look at these because I have doubts about a given event or a given special gateway that I only use 1 out of 1,000 times, and it's really indeed a very, so the core elements are swim lanes where you put lanes within to represent roles like actors in UML or somehow similar to that. You have flow objects that you put inside, which are typically events, starting events, intermediate events, and events. You put activities. Activities can be atomic or non-atomic, tasks or sub-processes if they can be drilled down. And then you have gateways, and then you can have several types of connecting stuff. Some within the pools, which are flows, mass sequence flows, and something that can cross pools, which are massive flows. And then you can also put associations with other elements like data objects and annotations and other stuff. But perhaps the most difficult part is this part of the events, because the semantics of events is somehow complex. It's related also to the display of the elements, depending on being somehow being able to interrupt other processes, and then it's on a sequential line, I'll say, or a dashed line if they are not interrupting. So if it's it's an intermediate thing, something that appear in the middle of a process, and in the end, well, for some reason, it's cut it a little bit on both. Also, I believe my line was full because it was said it was 16 against 9 the ratio, and it's not, because in my computer it works in here. I don't know if there's a display. Do you know if there's a display adjustment for these? Just try to show. In this particular slide it is not that much important, but in others will be. So I'm not sure. Do you have an idea of how can I adjust the size, because it's cutting the zoom? No, is that the word? Minus.
Yeah, minus.
No, but it's the minimum now. Well.
I think you were able to move the projector.
Well, maybe it's not okay. It's not critical. I hope. In most cases, but there's some bit cut in the top, so and in the right side. But okay, don't worry.
Without presentation.
Yeah. Well, don't worry. Well, I think we can live with this. Okay. All right. So let's move on. So okay, then we have lots of annotations, markers that go within the activities, markers that relate to the ability of being of tasks to be repetitive or not, to be able to be done in sequentially or in parallel, of being recursive activities, of being drilled down like the sub-process that you can click and some tools will go zoom inside and open another model. Tasks that work like rollback tasks, which have this symbol that allow, for instance, in a kind of transaction line when it's interrupt to roll back to a previous state, and other more, I would say, fuzzy stuff like ad hoc, which is something which is not whose semantics is not very well defined in the standard. Okay, and in the standard I mean about the OMG standard where the meta model is defined. Okay, so again, the activity types themselves, I hope you are used to these symbols on the left side. These are service tasks. These are kind for messaging. They can be white or black depending on being on sending or receive tasks. It can be something that not be done in a computer, something that you do with your own hands, and something which you do it as a person, as a user, and other things that can be automated like scripting and servicing, like assessing an API, for instance, or something like a script that you automate that runs in the night to make bank check compensation or things of the kind. Okay. Okay, and then you also have some other stuff which are reusable tasks, and then you put it with a more bold face border. That means that you define it somewhere, and then you can reuse in several other places in your model, while the others are supposed to be one-time definition. Okay. Okay, so let's move forward a little bit. These are the multi-instance activities. I would say these kind of very rich semantics that BPMN has brings problems for people that do tools, more advanced tools. Brings problems for simulation. It brings, because most of these things are not supported. It brings problems to animation. Okay, so the semantics of those things are not easy to show or simulate. Okay, so both in simulation and animation, and also, of course, there's a lot of those tool producers that use these kind of models to do to develop running systems, so to develop approaches of low code, okay, low code software development approaches. Usually these kind of more advanced semantical constructs are hard to implement, so I would say usually only a subset of the modeling constructs in BPMN are actually used in practice. And I've also seen on some consultancy works we do for companies that request it to the university. We've seen people in companies to also use a reduced set of BPMN for modeling their systems. I did some courses for people, for instance, in the finances and tax ministry, where they model very complex models. But I was amazed that they used only something like 20% of what's within BPMN. Okay. Okay. Let's move forward. Gateways. Also, most people use this gateway, this is so common that people can use like that. But not so often we find people using event-based gateways or complex gateways. So these one and these one are the most widespread ones. Connectors I've already mentioned, and I'm not going more details. There are rules for connecting. You cannot connect everything to everything. And fortunately, within a decade, we moved from template-like tools that you could connect everything to everything, like Microsoft Visio, okay, where you could connect everything. So it was like in the paper, everything goes, okay. So it was more, so you could connect everything to everything. Of course, lots of mistakes. Unfortunately, in the last decade, things have evolved where tools impose these rules, and so you can only connect things that are connectable. Still, there are some tools that don't do it, but most do. Most verify these kind of connections. Okay, and most tools also allow you to drill down somehow, and so show things as expanded views or compressed views. And also, in some cases, we cannot expand, because when you model, you often model things as collapsed views, some process, because you don't know what's inside. You don't need to know what's inside. You only need to know which are the messages that you exchange with that, like most web interfaces, where you only need to know which are the kind of, with REST interfaces, and you only need to know what goes and what you can receive back, okay? You also have events of processes, which is something also that is often not supported in automated parts, which allow you to have concurrency modeling. And then you have the artifacts, which are very important when you want to make data flows besides the processing flows, but you want to express that you share stuff either in a transitory way or in a more persistent way. So after the instance ends, you want the other instances to have access of something which was stored. Then you use that old metaphor of a disk to represent that type of information. Okay, and as I was mentioning, ISO in 2004 picked the OMG standards and became an ISO standard, and it hasn't evolved much since then. Okay, I mean the standard itself is something like a 600 pages long document with lots of UML diagrams expressing the meta model. Okay, this is an extract of the meta model. Meta models are very important for people that develop tools, because that's where the semantics for the modeling constructs are, and so to grant some ability to not have ambiguous models, you have to perform stuff upon the meta model. Actually, some years ago I supervised a PhD thesis, which is available, it's in English, which is I believe very interesting, where we used OCL, Object Constraint Language, upon the BPM meta model, which is very large, to impose and verify rules rules of construction of models, much beyond those connection things that are implied there. When you go and read the meta model, that's 600 pages long, there's lots of things which are in natural language. So lots of natural language constructs are not imposed, cannot be written as a class diagram. That's why OCL was developed. The OCL is the object constructed language, and it was developed for enriching initially the UML meta model itself, and then it became widespread. So just a note, it was something that we thought would be interesting for two producers. Okay, so that was my fast forwarding stuff, not so fast as I wish. So now I'm going to do the other fast forwarding stuff for the process mining, because we had so many presentations on process mining in this conference that I don't believe that vast majority of you are accustomed with this concept. So I make the poll again. Can I go fast here? Can I go fast here, or should I go slower? Process mining stuff. It's okay? Okay, so I'll go fast as well. Okay, so very fast. Okay. I picked actually this kind of introduction that you'll see in all process mining introductory courses, like the data and so on that you can find. This is from Eindhoven's materials. Okay, you have the systems that try to support operations again go on the world, and then of course those systems should be, in most cases, are process aware, so they have models of the process which is implemented in the software system, that somehow the models represent the ground truth, and the ground truths are not events, are what really is happening in the world, and then of course we can extract event logs from those systems. Event logs are things which have cases. Cases can be very different stuff. Can be, if it is in a buying shop, like in the grocery shop, it can be every time a client goes and buys something, that's a case. If it is like I was showing a car manufacturer, it can be a production line, so every car that gets out of the production line is a case. But it can be something every time I go with my credit card to an ATM with the card, I take money from the credit, or I have other information about my expenses, that's a case as well. So cases depend much on the context, but typically are things that can spread across time. Some cases take a long time, some cases can be quickly, can be almost immediate, depending on, so a car that goes in the production line, since it starts to be mounted until it gets out, it can take, I don't know exactly, but depends on manufacturer, but perhaps several hours. And a transaction like the one I do in the ATM, it will take 5 minutes, so it will depend a lot. So they have columns. The most important columns, especially for simulation, are, besides the information about the case itself, or if you want the process instance, because a case is a process instance, is the timestamps of how it starts and how it ends, when it ends, because otherwise you cannot know about the duration, unless you say, okay, when the next case comes, the previous one finished, and then you infer the duration. But that's a rough heuristic, a very rough heuristic, because there's might be a elapsed time. For instance, imagine the card example I was saying. You cannot say it took, the ATM can be completely alone for 5 hours during the night, and so the last transaction didn't elapse for 5 hours. So if you take the next time early in the morning when a guy comes and takes money out of the ATM. So usually you need more than just a timestamp. You typically need 2 timestamps, and you need to know which is the activity which is going to be performed, because CAiSE goes through activities, because a model has several activities. So typically for mining, both for mining purposes, but especially for simulation purposes, you need 4 columns. Then you can have others, but often they are not used. And so these are the typical stuff that you do in process mining. You do some quantitative analysis on the data you extract. You try to also to derive the process which is underlying when you don't have it, okay? Because often you have the process, but most other times you don't have an idea, or what you want to know if the process is which you discover matches the one you expect to be there. Okay, so there's the problem of checking conformance between the discovered model and the model which is actually, I would say, officially deployed. Okay, and then in the end you also want to do improvement on process checking. Based on all of these, you want to verify that there are some activities that are being performed that were not in the official model. There are activities that were in the I'll say the published model, but nobody is using them. There are transitions. Most often this is the case. There are lots of transitions that you never imagined could occur. And for instance, those transitions can be fake, can be examples of things that are only errors in recording, or can be things that should not happen but somehow happen, and you have to learn with that. And that's another image of Van der Aal's team about this, about the relations between the things that I can take out of event logs to discover process model, getting the conformance checking between the events and the model that you take out of events, and the one that you developed initially based on the knowledge of the reality, and the enhancements, which basically take both. Okay, take the model which is discovered and the model which is implemented or supposedly is implemented. Okay, and there are many tools, of course, that are doing that. There are new players emerging every year, and we've been trying some of them, of course, in academics, for that context I mentioned, which I believe is common. Universities cannot subscribe professional editions, because then we have dozens, hundreds of students, and licensing of this stuff is expensive. Okay, so we have to go and look and find partnerships with trustful tools. I would say as much possible as the ones that our students will be able to find when they go back to their companies, in case they are working, or when they go in the market working with. So we try to train them in professional tools, and not all of these players offer the opportunity for us in academia to expose our students to a reality which is close to the one they could use as consultants or in other roles. Okay, so that's also the reason why I made that initial acknowledgement in the beginning of my presentation. Okay, so I'll use this example, which is a depth version of an example which has been used around for several years, of a bank loan, and the original model. So actually, I use this model to generate events, synthetic data sample, and we actually, in the last 2 years, we use several tools to then teach process mining. We actually started 2 years ago with the Aris Cloud from Software AG, which is a good tool. Also allowed us to work in groups, in students, in the cloud, and it was a good experience, interesting experience. So these are some snapshots taken from Aris. Okay, so students would authenticate. They would load the data set. They would data set as a tool that allows us to classify which column is what, because so we have to define which are the formats. But most tools do this kind of stuff. Then we had to identify which were the activities. So these are basically the steps for importing data. Then these data sets would be available and could be shared across students. Those students would create projects, and this is also, I would say, Software AG also has an academic license. This was developed with an academic license, but which was, at least they said, similar to the professional part of the tool. Okay, so this example, by the way, actually we used two examples. PyThon was a Python hackathon we developed there, and then we collected data. I was mentioning that we are interested in the research part on software engineering, process management. So this was an hackathon, which was to control if students that never had Python before in courses where they only learned Java, if they could learn within 3 days based on a MOOC, on a massive open online course, we in-house. So it was a controlled experiment with a room with 200 people from many courses. We closed the door, we offered them food, okay, and they stay there, everybody doing the same learning process with their headphones. Nobody could talk with nobody, and then they were following a course by an American university on Python, and then never had Python before. And then in the end, we did that hackathon with an automatic judge, like ACM and IEEE contests students. So it was very interesting. And then we wanted to know what happened and understanding the strategies of our students in solving the problems in the last day, in the last day where they did where they were compared with the students that on a new master program that we have, and actually a bachelor program, actually not a master program, that is also bachelor students. We have for 3 years now we have a new BS degree on data science, and those students only take Python from day one. And then we wanted to compare, and we found out that it could be, the other ones could do better after a 3 days intensive day than the others that only did Python, because they have more diversity and so they have more trained minds. While one's only had Python, the other had several languages, no Python but others, especially Java, but also others, C++, C, and so they could do better than the others that only did Python after as few as, I'll say, 20 hours training, intensive training. Okay, but let's close the topic. So this kind of analysis, this tool has allows you to have tools like dashboarding stuff. They call it, they can be customized dashboarding, but they have what they call the app builder. They have a process overview, which is a standard dashboard, and then they have the process explorer, which is something we are more consistently used to consider. Process mining, which is getting the model, actually discovering the model. Of course, it's activity follows model. And we didn't get very happy on that because we really wanted to have BPMN, and so it was interesting to get by the way, these are the problems they were exposed to. Problem 1, 2, 3, 4 were the problems they were given on that competition last day I was mentioning, and these are the transitions that they made. Okay, by the way, the vast majority of students started by problem 1, which was, we said these first two were the easiest ones, 3 and 4 were medium complexity, and 5 and 6 were the highest complexity ones. So the vast majority of the students, of the finalists in this process, because we had kind of steps, they others thought it was too simple and jumped directly to P3 and so on. Okay, it was important for us to understand what happened, and this was a good, besides the teaching part, it was interesting for research as well to understand and describe the experiment. Of course, this kind of mining tool allows us to reduce or amend the activities and the connections and so on, and look what is the happy path and so on. Okay, so this is the full model, which in this case was relatively simple. You have, as you see, you have here you have 200 students doing their work, and the vast majority here it's no, sorry, here that's another example. This is the bank one. So this is another example with the transitions. But if you look at this example and the original one, it's difficult to map one to the other. There's a great difference between these and these. Okay. Of course, you can recognize the activities which are there. Also we have events which are transformed in activities in those discovered model. So we gave up ARIS on the first year. Okay, it's not because it's a bad tool; it's because it didn't match what we expected. So then we got our hands last year on Abreu. Okay, Abreu is also very interesting as that academic licensing program. It has a very interesting dashboard. I would say maybe a little bit better than ARIS. Not as much configurable as ARIS was, because we could build stuff from scratch on the other tool, like in a kind of programming drag and drop approach. But for our students it was perfect, because we wanted them to advance rapidly, not to start developing apps. So, for instance, in the same example, if you go here, if you count them, you'll see there are 17, except the if you count those activities and events, except for the start one, because there's no time expended on the start event. Okay. So we could have some kind of dashboarding with the distribution of frequencies and other representations. So this is the standard dashboard. We could have the model discovered in a similar version actually with ARIS. So we didn't improve that much on that aspect. Although I must say I was tricked initially, because there was a button here that's saying, well, let's get the BPMN model. Okay, and so this is the model recovered in what Abreu in this version, which is actually the current version, calls a process map, which is the activity follows map, and this is the equivalent when you switch to BPMN. Basically, the gateways are recognized. For instance, here you have 2 flow out and 1 flow in, and then of course this allows to say this is a merge. So the I believe it's split minor algorithm allows you to discover the splits and the joins, and also in cases where it happens, it allows playing with the parameters of parallelism and arcs. You can the sensitivity allows you to detect parallelism and detect parallel gateways, and that's all. It allows to do something which was very interesting and we didn't get in ARIS, and so this was an improvement definitely, because students love this. Okay, they love to see animations, so they enjoy these a lot. Okay, so just click a button and see the animation was wow. So they got really enthusiastic on the first class on the ability of looking at things moving and seeing the instances, and this allowed us to introduce the topics of delays and say, what does this mean? What does the things that mean that are in this case? they're not, but when they're being processed, the markers are within the activities. So we could explain the concepts, and they could see it moving. So it was, and they could stop in the timeline, and it could be quicker or slower and go back. So this was, I would say, very educative for us to see the dynamic nature of processes. Because people, when they only see the models, they only look at the static stuff, and they somehow don't click to understand that this represents actually what's there, okay? And that this is very important for people to get the ideas about processes, to understand, to look at them running. It's really interesting. So the dashboarding was, I would say, more than enough. Of course, the part on the coverage, I would say, of the concepts still lacks what we would like to have in the opinion. Please.
So, according to your experience, you're saying that all of the constraints cannot be really mined from the event nodes. Do you think they are actually needed to create a better model, or do you think they are kind of alternatives?
Yeah. Oh, wait. Okay.
The event is very rich, but then it's over the question: actually, is it needed?
Is it needed? Yeah, that's a good question. Going back to what I mentioned, the experience I have from people in companies that they do not use everything which is available, but role assignment is very important. Okay, so who does what is, I would say, it's one of the most important stuff, and this does not capture that. So I would say, if I want to take something out that I really need to have here, are pools and lanes. Okay. That's really, I would say, a must. And so I will progress in the next years, this year, so to try to find an environment which can be open in the sense that we can use with students, and still has this kind of capability. There have been in the research, for instance, I recall, I think I have mentioned here in a few slides, in a PhD thesis on Van der Aal's teams in Eindhoven, something like in 2014, I believe. They developed a tool, a plugin for one of those 200 plugins that the Pro-M tool has, okay, which are very difficult to install, to configure, which are not documented, which are terrible for this kind of students I have, okay? So it's, but they have developed a very interesting tool to reverse engineer, was able to capture, to recover the roles out of the diagrams. Sometimes perhaps with some additional column that allows you to have names of people or names of something or matriculations of cars or something that allows you to improve the clustering algorithms, because usually that recognition is based on clustering. Okay, so this is what I found in Apromori site mentions several, I would say they call laboratory extensions, plugins, and then in this case, which is the one that interests me, this BPM Miner 2.0. I think, but then I will confirm later with somebody which is in the room. This is related to this split miner paper. The people seem to be exactly the same, although the name is not the same. And although I must confess I couldn't understand because I downloaded this, but then I found it mentioned it's already embedded in the. So I guess this is the button. That button for the split miner is that button. But then is that? So that's the button. I understood it was. So okay. So it's interesting. But then I was reading this paper 1 or 2 days ago in the evening, and in the end there's lots of the limitations, of course, mentioning what is not covered. That's basically what I was mentioning before. But of course, I expect to have advancements on these. And that is the paper, the work I believe it was must have been a PhD thesis by that Anna Kalenkova in Banderal's team, where, and I was once able to run this. Okay, notice what I'm saying. I was once able to, because after I came back and tried again to do with my students, and I wasn't able anymore. So it's okay. So definitely ProM was not developed with usability in my great work, great research work, but that's it. It's not for well. Actually, they have developed. Now they're developing commercial tools and have been doing it for many years, and now especially Celonis line of products. So of course I'll have to have an eye on Celonis as well next year to see if it's better than Apromore and see if I can solve my problem. Okay, so that's all. Let's move forward. Let's go to the simulation part. Okay. Oops. Time flies. Okay, so simulation part. Okay, so let's move. Okay, it's quantitative. I believe most of you also have. You have seen the animation part. All of you know that simulation is being used in all areas. Okay, okay. So it's not new in other areas. I would say it's compulsory in many areas, but in other areas it's new. For instance, this is my own research, ongoing research on using simulation models for crawling. Okay, so we are using a platform. It's called Gamma by some French team, which is spread actually also to Vietnam, and where allows you to make simulations with thousands and thousands of agents. So we programmed with a DSL, the domain-specific language. We programmed the behavior of agents, and then we can do simulations. For instance, this is an example of an egress simulation. That's the actual place. That's my team when it won the first time in a row championship of football. And we want to understand how people behave, because then we have the local authorities. They want to know what they must do to follow with the police, with the medical to be assigned. Like you see some ambulances there, and you have to be, and also the cleaning stuff after people leave. And you have to have strategies to allow the people to get out, not to block some entries and so on. Sometimes we wouldn't like people to get out of this door, but if you do some simulation, we find out it's a better idea to open all doors or something like that. So this kind of work we've been doing, also related to tourism happenings, and also studying about behaviors of agents in groups. For instance, here is a group taken out a sequence of time, and the groups, the members of the group here, they, as you see, their trajectories, because we just highlighted one group, they don't go straight because of the interactions, and mathematically we can model the interaction. So this is another example of process simulation in a rather completely different context. Okay. So simulation, we can, of course, do things which are interesting in information systems, generally in companies, which is related to time and cost aspects. We can do it before deploying the process in place. For example, you will not open a huge hypermarket with lots of cashier doors while not doing some simulation there, because you have to figure out for that kind of capacity, for the type of sales you have in that region, how many way outs you need, if you need to contract people, if you have 20 boxes, which are the schedules that you need to have people to be there, because you don't want to pay 20 people to be there, just waiting that somebody comes. Okay? So, and it cannot be an on-demand, just-in-time process, because then you will need to pay for them to be there, to go to the cashier, okay? So this kind of stuff, it's not only to be done after things are in place, but also we do simulation before things happen, like in other industries, okay? We don't send a jet to Mars without lots of simulation, because it's much more cost effective to do simulations than try and error, okay? Okay, and also because you want to have what if scenarios. If I do that, and if it increases, if that and that and that. So to do what if scenarios, simulation is very important. And then you want to make questions and answer those questions about if I change this little bit in the assignment of resources, if I double the number of resources, if I reduce, if I pay less, if I pay more, if the number of, so the pattern of arrivals changes, how things change, if I modify the shifts in which people work, or if the availability of my server, okay, for instance, in my problem, we are developing a recommendation tool, and we have to make simulations for that app to see if then we'll have an exponential growth of people using the app, how it will behave our server, or how many cores must we install, how many memory, and so on. So we have to do this kind of simulation. So this very similar to this that we can do here. So there are many questions that typically people want to ask, namely about where money is going to, if there are bottlenecks, and if a given role is having more throughput than others. So to configure out the balance between the roles, it's something which is very important and can be only done with simulation. But simulation comes at a price. Simulation is not reality, okay? So we have many limitations that we should consider, and well, in science we would call validity threats section of our paper, of our thesis. And here we also have lots of validity threats we should be aware of. There are some strategies that we can use, and I'm going through them very quickly. We should, okay, let's fast forwarding. We have these problems of stochasticity, the data quality, and assumptions. Okay, so these kind of problems arise from stochasticity problems depend on running a simulation, and the results get different because we have to assign a distribution of probability to each activity, and the conjoint distribution is not possible to derive, I would say, algebraically. And so when we run, different runs might yield different results. Then also we have the problems of the beginning of the simulation, the end of simulation. Resources are not assigned, and so we have a transitory phenomenon that we should not consider as very important, not very interesting. And then we can also have trends, variability, which can be affecting our results. So there are ways of counteracting these problems, like running multiple simulations and getting averaging the results and developing in confidence intervals. Of course, this requires that our simulation engine is able to run and compute those confidence intervals. Unfortunately, not all simulation. This seems to be a thing which is, I would say, easy in CAiSE to implement, but I haven't found it in this kind of BPMN simulator engines that we have. That's very, I would say, that would be very interesting to have, to see. Not only producing, see, that's the result of this simulation, okay? But the computer can run 100 simulations in a row. It will take a little bit more, but then it will provide confidence intervals. Okay, another problem is that of the beginning and the end. That's easy. We can, for instance, BIMP, which is the simulation engine we use, developed by Brito, allows you to cut the beginning and the end by a certain percentage, and that's very interesting to avoid the initial and final periods where the model behaves differently. Because, for instance, in the end, the guy in the supermarket say, "Oh, we're going to close," and of course, after 10 minutes, nobody is in the cashier, and so it's useless to have people there, and the model behaves completely differently from reality. Okay, the issues about stochasticity related to trends, and so we have techniques in time series that allows, and that's something, another thing that which would be interesting to have in simulation tools would be to decompose, because these algorithms are well known, they are implemented in tools, in time series. In a simulation, the results, in fact, are time series, okay? So these kind of techniques which allow to do seasonal decomposition and trend analysis and get the noise, it would be interesting to have this kind of stuff. And it seems to be also easy, I would say. Of course, you have to convince people, but if it's not available, people don't use it. But it's not only for research. I believe this kind of understanding that my data, my events are having a trend that can be taken out of the simulation data would be very interesting to see seasonality if it has. To get the trend if there's one, and take the noise out of it. So it would be, I believe, of course this can be done in costs, in times, in waiting times, this kind of variables, and I would say these could be, of course, data quality is about the parameters we can get, and that will get us to the problem of having good samples, and that's what we're going to see in a moment. And finally, we have the problems of simulation assumptions that we have, and that when learning about simulation, we have to be aware of is that we usually don't have multitasking. We have no teamwork. So our process instances are going to be served by resources. Resources are instances of the lane, okay? And we cannot assign to the same case two instances of the resources. Neither can an instance of the resource work on two cases at the same time. And that's not real, let's face it, okay? That's not fair, because we more and more, like you doing now, you're doing several things at the same time. You're answering your email or whatever, and you're perhaps, I hopefully, also hearing to my talk. So we are used to do more and more used to do this, and so when we have humans on simulation models and on information systems, of course we have humans, then this reality is not easy to embed, okay? For instance, yesterday, I believe, or 2 days ago, our guest star is going to be Manuel, is going to come to show us the problem of the quality. How can we solve the problem with the data logs? What can we do to clean them, to improve them? So our simulations can be better. He made a presentation about deep learning, the use of deep learning, and I believe deep learning, that actually was my question that I asked him. I believe that deep learning techniques they not need to be deep learning. It can be only machine learning. Machine learning, deep learning is a bit too deep, I would say, for this kind of stuff. So, but machine learning techniques that we have nowadays could allow us to get profiles out of humans. Okay, so I would say using machine learning, I believe it would be possible to identify that's John, that's Mary, that's okay out of the events performed in a company. For instance, if you record events, maybe you don't know who did what, but I believe we could learn the human variability aspects and put it in the simulation, which would be a big improvement. Because the other stuff are not easy to model actually in a simulation model. Of course, that's my. I have lots of things, many more things to tell, but now I'm going to give the floor to to Manuel. Manuel is working, has done his PhD on in a joint cooperation with R2 at University of Los Angeles in Colombia. He has defended his thesis in January. I read everything about him before, and then I figured out he was coming to the conference. Okay, I was reading a paper precisely on CMOD, which he's going to tell you about, and yeah, just take
it's
out.
okay if we can connect.
Yeah, and then actually I have a YouTube video in my slides where I suspect the voice belongs to you.
Probably yes.
and so that's what I was going to present was the demo of CMOD. And then I figured out the owner of the voice was here. So it didn't make sense to do that. So, Manuel, thank you.
Okay. Thank you so much for the introduction, Fernando. Well, I want to share with you a little demo of CMOD. CMOD is a tool basically for automated discovery of simulation models. Many of these topics, can you see in there? Fine? Yeah. Okay. Many of the things that we were watching about create simulation models, they seems like very simple, but for a normal person it's very complicated. As well, we have, of course, what is the motivation behind CMOD? The idea is that we want to have a very reliable CAiSE representation in a simulation model for a start to perform what-if analysis, right? If you have a base in which you can trust, you can modify that base, and then you can have results that you can actually trust in and maybe apply that in real life. That's the main motivation. But then when we have a tool that can create models, we as well have like a set of parameters that is as well huge. So it's like we are translating transferring one problem of create simulation models from zero, then to define a set of parameters that can be as well technical and very complicated. But CMOD is a tool that is able to find parameters on every process mining tool that we are using and just give you the final simulation model in which you can start to work with. And before to start, explain a little bit more of the details, I will start to run CMOD. CMOD is a command line tool, so and we can later check what it's doing. I want to just show you that it's executing meanwhile I'm explaining. So let's see. Oh, since I didn't copy. Okay. So I will leave this thing here running. Yeah, should be. As always. 1 second, I will change the folder. Always when you are doing a demo, these things tend to happen, no?
We know.
Yeah. Okay, I think there should be fine. Let's see. Yeah, now it's running. Okay, so meanwhile, the steps inside CMOD. The method that is behind CMOD is composed of these steps. Basically, we start by discovering a control flow model. It's a VPN model, right? Yeah, it's a VPN model, and this is our base. Using this VPN model, we take the event log and we start to replay the event log for calculate the branching probabilities. Once we have the branching probabilities, we can go and continue with the, let's say, the discovery of the simulation parameters. So we can discover the pools of resources, we can discover the distributions of the activities, the durations, we can discover all the components. I will explain a little bit later, but we discover all the parameters. We have these parameters and then we assemble all of them. We pass all of this to a simulator. Right now we are working with two different simulators. One is BIM, the one that is embedded in a Promore, And Prosimos is a new simulator that we are like starting to use and try inside the research group. Prosimos is a simulator that is able to execute, is able to not only to manage resource pools, also to manage individualized resources. So it is very useful when you, for example, have an activity that is being executed by 2 different resource pools and things like that. So it's a very detailed simulator. And after doing this part, let's say we are just creating and executing one event log. You can find many other pipelines like this in research, but something special with CMOD is that it's able to measure the accuracy of the model. So you can start to know, okay, this model is good or not, right? But more than that, is able to optimize this model. So if you know if the model is accurate or not, you can maybe modify the parameters of discovery and try to get a much optimized simulation model. So this is like the method, and a little bit more in detail. Is okay. A little bit more in detail regarding the pipeline. This is the real pipeline of the tool, right? So we have inside CMOD actually 2 optimizers, and we have 2 phases. In the first phase, we are discovering everything related with the structure and the control flow. So is the VPN model and all the branching probabilities. With this part, we are able to generate traces without time, but we are able to do it. And then we have an optimizer that is using the Merrill-Levenstein distance for optimize the structure. When we have this structure really the most accurate possible, we move to all the time-related parameters. So in here we start to discover interarrival distributions, activity distribution, roles, instances, calendars. Calendars is something super important because we know that in real life resources, well, mostly they are not available all the time. So now we are able to discover calendars for the generation of the instances and for the work of the resources. And then we start to optimize as well this time discovery. But in here we are using a different metric. We are using the earth mover distance to compare like different distributions. And the final product of all of this is a simulation model in which we can like rely on. Now let's see how it's doing CMOD. How was doing it? Okay, it's running and it's in the final comparison, so it was just in time. Great. So as you can see, well, it's finishing. This was the execution of the tool. We will start from the beginning. What we were passing as a parameter is a configuration file. This configuration file basically is this one, and what it contains is basically the details of the event log, well, the name of the event log, and all the ranges in which we want to discover the components of the model. So in the first part, if you check in here, we have the structure optimizer. Is the first the structure discovery and all the parameters. For example, we have in here epsilon, eta. These are parameters that specifically are from SplitMiner, the tool that is embedded in Abreu. We have in here different options for discover the branching probabilities. We can assign the same probability to all the branches in the gateways, or maybe we can just discover the probabilities by replaying the algorithm, the event log. And in here we have all the ranges of the parameters, as you see. We have in here other feature, the repetitions that Fernando was talking about. In the demo I'm doing, we just execute 1 repetitions per experiment. We can define even 10 repetitions, and all of them will be running. As well, we have in here this parameter, max evaluations. That means that the hyperparameter optimizer will be executed the number of times that we want. So meanwhile, more repetitions we assign, better results we expect. And this is let's say, all the input parameters of the tool. At the end, we have, let's see, what was the final folder. That was the result. So we have this folder is the 3040 FC7. So it's this one. In here we have the simulation model. This is in the format of BIMP. We have a canonical model in a JSON format. This is specifically for the Proximus simulator. And we have metrics that are basically what was calculating the tool. For example, as I defined just two, in here I have the results of every execution. So this was the first results. And the final evaluation of the model is in here for every execution, right? So it's a set of metrics that we can take. As well, we have in here the event logs that were generated in every run. So we have in here all the event logs that were generated. It's a whole package. And then what we can do now, let's say the work of CMOD finishes in there, but maybe we can use this model, is this one, and we will open the model in BIMP simulator. And this is the simulation model per se, is all what we discover. As you see, we have in here exponential distribution, the value of the distribution, the number of instances. We have the resource pools, the number of resources per pool. In here we have the timetables, and as you see, these granular tables are very, very detailed. So we have some spaces in which the resources are available. We have in here this is for the generation of instances, this is for the resource pools. In here we have the tasks and all the values of the durations and the different distributions, as you can see, and the roles assigned as well for each activity. So all the simulation model is discovered, and in here as well we have the probabilities of the gateways. So just for try if the model works, we will execute it, and then now we have the metrics that basically we can start to analyze. And if we use this model in Apromore, we can maybe take the original event log and compare both of them and start to have some insights about what we can change. So yeah, well, this is CMOD. So if you have questions.
I would like to, after you change, I would like to show then afterwards what we did to solve these same problems back there in Lisbon. But yeah, please.
Yeah.
Not yet.
You showed that the result of the mining been recorded in BPMN5, and
yeah.
then you uploaded the file on BIMP. So I suppose that in BPMN5 you also put the simulation parameter.
Yeah, yeah.
I was wondering which notation you used for the simulation.
For this one is actually the notation that is defined for BIMP. They have their own set of parameters, and everything is defined in an XML.
Standard for that. I was wondering.
Well,
if you are using BPSim, it's called.
Uh-huh.
It's a standard for putting simulation parameters on BPMN. So I was wondering whether you were using it.
No.
If not, why?
Well, basically we are using the one that is provided by BIMP, because otherwise that simulator is not able to recognize the parameters. Let's say it's a limitation of the simulator. So if the simulator needs the parameters in a specific format, we can produce it. let's say we have an internal representation of the parameters inside CMOD, and we can export to different formats according to what is required.
Okay, no, because I'm working with BBC, I was wondering whether you see some limitation, some problem with that standard, because
Okay.
in the presentation you're using DPMN, so I suppose you are favorable to standard.
Yeah.
And I see that BBC is not so well spread like BPMN, and I'm wondering why.
Yeah, I think basically it's because every simulation engine has their own proprietary formats that they really don't want to be guided by a standard, I think.
BPMN. So before BPMN, every modeling tool had its own rule, then all the people came together with the OMG and they brought the standard. And as far as I know, a similar approach has been taken from BBC, and it's supported by some vendors like, I don't know, Trisotech or Visagi or other tools, but I don't see the same level of
Adoption.
sorry?
Adoption.
Adoption for BBC rather than BPMN. So I was wondering, since you are expert on this, there are some internal problems in BBC that.
No, I think it's more in the side of the vendors. If they decide that for them is not something that they want to be guided for, maybe because of performance or maybe because it's more complicated to do it, they will go for what is more for the key performance indicators they want to benefit, basically. Yeah. So yeah, we are working with the format. That's why actually we have a canonical model, because if there is no support, you can just simply take the values and do it manually, because there is no other way, or take the canonical and transform to the format you need. Yeah. Okay, so I will leave.
Just to wrap up, thank you. So thanks a lot. Let's just put it. Okay. So, by the way, that's a very interesting issue, and actually we took a somehow different approach to getting the parameter for the simulation, and if the next simulation engine we will use will support BPSim, we can easily do that, because actually we did this well, somehow similar but not as sophisticated in some aspects as you have seen. Let me just try to project. Okay, so just let me go fast forward this, because I put my, okay. This is about the resources. No, it's not. You have to click here. Okay. Okay, this is explaining activities and so on. About the statistical distribution, I will give you these materials, which are, but for the business process simulation features, we did actually. I developed a meta model of the simulation process, which is well developed. Actually, we will publish that in a paper soon. But we did it in a rather different way. Basically, we did with our student. That was also a chance for our students to get some hands on R, because they didn't get on other courses, and that's important stuff for many data science stuff. And so we found two good packages on R for distribution fitting, which is the most advanced problem here. And so we did it here. Actually, I will give you the report, the technical report we developed, myself and a colleague of mine. I know he's a colleague of mine, but he was a former student of mine. Just a moment. And you'll see it has some some art stuff in it. A moment, I'm going to pull. Okay, so basically, João Caldeira was my finished his PhD last year, and so that's the document we developed for our students for learning how to do all this stuff. So they have to install R and the libraries, and then they have to do some data preparation on the data sets. They formatting dates and time columns. Then they view data set. Then they filter out. This was for them to understand when each event started. The order stuff for them to understand. We computed intervals between CAiSE and instances. We computing the elapsed times for the activities when we didn't have them, so we had timestamps. Here we calculate the instances arrival intervals, and then we use this Cullen and Ferry graph, which is a kind of a visualization of distribution fitting. Okay, so you see here normal. So if our observation goes, so if this blue dot, which is the observed values from the data set, goes close to this line, it will be a gamma distribution. Here is on the beta distribution area. It's a strange diagram, but we tried with some other tools, and it provides good answers, visually visualizable for them. So if it goes near this, it will be a kind of exponential. Here it's a kind it's close to normal and uniform depending on. So it's sometimes it's difficult to discriminate between very different distributions, but that's something I would like to do within a few months, is to pick CMOD and doing it in R and compare the fitting and see if so I'll probably put the students working on this after next September, comparing not only with CMOD but others that we will find a simulator, picking the same data set, same log of events, and doing it. So of course we have to do several trials. We have to do this kind of matching, this kind of so this you'll see lots of diagrams. Of course the diagrams are slightly different depending on the data sets, this Cullen and Ferry graph, but the basic idea is also always to see which is closest. Although in command line we can get a recommendation. This is the visualization. In some cases it's very clear, other cases are less clear. So of course we also have to have this kind of distributions of fitting the cumulative distribution functions versus the data sets. So this is a very good fit, of course. These PP plots and so on for the distribution. So I would say when we arrive to these kind of diagrams, that's it. We are doing almost perfect fit. So this kind of thing, but it's lots of work. Okay, it's lots of work. So in the end, the academic part of this is very interesting to do for research purposes, not on a master's degree where you want to introduce several topics where people don't have much, lots of background on statistics, and so because you have to explain all the diagram, what they mean, the distribution, they have to learn how to program all scripting in R. It's interesting, but it takes time. So I would say I was enthusiastic when I saw something that wrap up this complexity in CMOD, so I most probably will try to use it next semester. And okay, I do have also examples of trimming down, of trying to configure costs and times aspects and balancing the distribution, but we don't have time because we arrived to the deadline. So I just want to go to the last slides. So I have a force collection. So I will give you 4 collections of slides. There's a final one with optimization aspects, which let me go forward, which is discusses how where can we get data from ERPs and so. Oh, he's saying it time's over. Okay. Sorry? Yes, I'm not. I'm just. I was just running to the end. So. Sorry. This is. Okay. So as I was mentioning, next time. Wait, I'm going to close these. Okay, hopefully now it will pop in a moment. Okay, so as I was saying, here you have the description of that meta model, so you can go through. So I'm sure all of you know about UML, so you will understand easily the steps that you develop here in this meta model, and where people can get data. So that on the ERP systems when it's not provided. So this is description of the meta model. Here is what Manuel has just shown about the configuration parameters of the simulation engine, and some recommendations to save the scenarios in between, because it's a good idea to do that. The export parts, because we can export these in, for instance, MXML, which then you can use other tools like, and we have been using it in ProM, some tools for instance, to use that plugin I mentioned before, and for getting the BPMN models. And finally, you can see, of course, and we tell our students to go and see the hotspots, where time is spent, where money is spent, and so on, and the KPIs, and then the scenarios where they have to pick. So we give them a challenge to do this balance of cost and time and quality. So they have to express SLA and the service level agreements, and they have to try to comply. So basically they extend they try to put the productivity of participants to the maximum until the point it degrades the quality. I mean, the delivery time starts to of course, when resources are not available, waiting times start to grow very, very fast. So basically these are kind of things. Okay, so then you can see the examples they have here, and ultimately we use the tool which is more widely used worldwide, which is the tool that companies worldwide use the most. Excel, of course. So we export data and make some work in Excel as well. And also we have to use some tricks. For instance, BPMN being exports things in gunzip, and so our students have no idea what's gunzip. So there's some online tools that allow them to extract until the point they have MXML and so on and so on, and then we import that in ProM. So it's a long story cut short. In the end, they have to clean so here you have the instructions to get the output of BIMP, which needs to be cleaned to be imported in Excel. So here you have the extra instructions of what do you need, and you have to do some transformations to be able to import BIM simulations in some some lookups, more or less sophisticated, to be able to twist around information in such a way which is amenable to data manipulation in Excel, and that it's explained in detail and it's well polished because they have tried this. Okay, so this is something that you could use very easily, and you have to eliminate duplicates because the generation data in BIMP, at least the version we used some month ago, generates duplicates, and in the end they get a clean stuff like this. Okay, after several transformations. Okay, so nothing is easy in the world. Otherwise, also we would not need to have people with knowledge on computing to work on these. So that's the thanks to. This is the best picture I could find of it. It's not easy to get you on the internet. Huh? It was the defense. That was the best. You were empowered picture, so I guess it was. Okay, so, and then, okay. So, thanks again. So this is I must say, this was the paper that inspired me to bring Manuel here today. Okay, so let's thank Manuel. Thank you.